What if everything we thought we knew about the universe was wrong? What if the story of the cosmos, the Big Bang, the birth of stars, the evolution of galaxies, wasn't the beginning, but just a chapter in a much deeper mystery? In the summer of 2025, scientists working with the James Webb Space Telescope, JWST, released data that shook the foundations of modern cosmology. Webb had detected something so strange, so impossible, that even seasoned astronomers refused to believe it at first. It wasn't an alien signal or a new planet. It was something much older, a star that appeared to be older than the universe itself. For decades, cosmologists have agreed on one fundamental truth. The universe began about 13.8 billion years ago with the Big Bang. Every star, every planet, every atom of matter emerged from that moment. Nothing could be older. But now evidence suggests that this rule may have an exception, one that rewrites the story of creation itself. When the James Webb Telescope first began sending back images, the world was stunned. Galaxies that were supposed to be faint smudges appeared as fully formed spirals, too complex, too early. The telescope's infrared eyes pierced through the fabric of space-time, allowing us to see the universe as it was just a few 100 million years after the Big Bang. Yet what it revealed made no sense. Galaxies that should not exist, stars too massive and ancient-looking to fit any model. Then came the real shock. In early 2025, a team analyzing data from a region known as Glass Z13, one of the oldest observable areas of the cosmos, found a star whose spectral signature suggested an age that predated the universe itself. Its light, stretched by billions of years of expansion, indicated that it formed at least 14.5 billion years ago, a billion years older than the cosmos is supposed to be. If that number is even close to accurate, it breaks the laws of physics as we understand them. At first, scientists assumed it had to be a measurement error, perhaps an illusion caused by gravitational lensing or dust distortion. But repeated observations confirmed it. The star's elemental composition and light patterns were consistent with something impossibly old. The star, unofficially dubbed Methuselah II, mirrors a famous anomaly discovered decades earlier. A similar object known as the Methuselah star, HD 10283, within our own galaxy. That earlier star had also seemed older than the universe, though later refinements brought its age just below the cosmic threshold. But this new discovery, found far beyond our galactic neighborhood, defies even that correction. Methuselah Secum's chemical fingerprint shows unusually low levels of heavy elements, like iron and carbon, meaning it formed from almost pure hydrogen and helium, the same materials left over from the first moments after the Big Bang. Yet somehow, the ratios don't match the expected distribution of early cosmic matter. Its light tells us it's not simply an ancient star, it's a relic from a time before time, as we know it began. To understand why this is so puzzling, we have to remember how stars form and age. Stars are cosmic forges, born when clouds of gas collapse under gravity. The first generation of stars, known as Population 3 stars, were massive, short-lived giants that burned hot and died quickly, scattering heavier elements that gave birth to later generations. Every star we see today contains traces of those earlier explosions, the fingerprints of cosmic ancestry. But Methuselah II lacks those fingerprints. It's as if it was born before any other stars had exploded, before there was enough time for heavier elements to form. That would make it a Population 0 star, something cosmology doesn't even have a category for. If this discovery is real, it suggests one of two possibilities, both astonishing. First, our measurement of the universe's age is wrong. Perhaps the Big Bang happened earlier than we think. The second, far more mysterious, is that the Big Bang wasn't the beginning at all. Several new theories are emerging to explain these paradoxes. One of them proposes that the universe may not be a single event, but part of an endless cycle of expansions and contractions, the Big Bounce model. In this scenario, the universe collapses into itself, then explodes outward again, creating new space and time. If that's true, Methuselah II might be a survivor, a remnant from a previous cosmic cycle, a star that somehow endured the death and rebirth of the universe itself. Another possibility involves quantum tunneling between universes. Some cosmologists now believe our universe might be part of a vast multiverse, a cosmic foam where universes bubble, collide, and transfer matter or energy between one another. If so, the star Webb observed could be the faint echo of a neighboring cosmos bleeding into ours, light from an earlier creation crossing the thin boundary of time. Whatever the explanation, the implications are staggering. If the James Webb Telescope is detecting objects older than the universe, it means our understanding of space-time, gravity, and the origin of matter is incomplete. Einstein's relativity describes how space and time bend under gravity, but it doesn't explain what happened before the Big Bang. The discovery of a pre-universal star could be the first direct evidence that time itself has deeper layers, that our cosmic clock didn't start at zero, but reset from something before. Astrophysicists are cautious, but behind closed doors, many admit this discovery could change everything. We may be looking at the universe's DNA, one researcher said in an interview. If this star is real, it means the cosmos remembers something older than itself. The James Webb Telescope wasn't designed to find paradoxes. It was designed to trace our origins, to look back in time and witness the first light after creation. But like all great discoveries, it has raised more questions than answers. Among the most startling findings is how mature some of the early galaxies appear. The Webb images show fully developed spiral structures just 300 million years after the Big Bang, a cosmic instant. According to current models, galaxies should take billions of years to form such order. These galaxies are also producing stars at rates far beyond expectation, suggesting that the universe may have had a head start, or that something accelerated its development. Could Methuselah II and these galaxies share a hidden connection? Evidence that creation didn't begin at a single point in time, but across multiple phases of reality. In laboratories across the world, scientists are reanalyzing cosmological constants. The Hubble constant, which measures the rate of cosmic expansion, has already been a source of controversy. Measurements using nearby stars and distant cosmic microwave background data yield conflicting results. If the expansion rate is wrong, then our estimate of the universe's age, 13.8 billion years, could also be off. A slightly slower expansion would push the true age higher, perhaps to 14.5 or 15 billion years, making Methuselah II no longer a paradox, but a revelation. Yet even that adjustment wouldn't explain its composition, the purity of its light, the absence of later cosmic elements, and its improbable stability over billions of years. It's as though this star belongs to a universe with slightly different physical laws, one that left its mark in ours. This discovery also reignites ancient philosophical questions. If there was something before the Big Bang, what was it? A vacuum, a previous universe, a timeless state of energy and information waiting to awaken again. Some scientists now speculate that information, not matter, might be the true foundation of reality. If that's the case, then Methuselah II could be a fragment of encoded data, a cosmic artifact that survived the last reset. In that sense, it's not just a star, but a message, evidence that the universe has memory. Others take a more spiritual view, seeing this as proof that creation is eternal, that the universe is not a single event, but an infinite unfolding, where beginnings and endings are illusions. For centuries, ancient traditions have spoken of cyclic time, From Hindu cosmology's endless kalpas to the Mayan belief in repeating ages of creation. Perhaps modern science, in its quest for certainty, has merely rediscovered what ancient wisdom always knew, that existence has no true beginning or end. Even as scientists debate, the James Webb Telescope continues to scan deeper into the cosmic past. Every new observation pushes back the boundaries of time. With each image, we see not only galaxies and stars, but the reflection of our own ignorance, the vastness of what we still don't know. For the public, these discoveries ignite wonder. For scientists, they ignite revolution. If Methuselah II and other ancient anomalies are confirmed, physics will need a new framework, one that unites quantum mechanics, relativity, and cosmology into a single story of reality. It could be the dawn of what some are calling post-Big Bang science. But perhaps the greatest mystery is emotional, not scientific. When we gaze at the light from that ancient star, we are seeing photons that began their journey before time as we measure it existed. That light traveled through countless transformations, expanding space, shifting galaxies, cosmic storms, to reach our telescope. In that sense, the universe itself wanted to be seen. It's as if the cosmos has been keeping a secret, waiting billions of years for us to look deep enough to find it. The discovery of a star older than the universe challenges not only science, but the story of who we are. Humanity has always looked to the heavens to define its place in creation. Once, we thought Earth was the center. Then we learned we orbit a star among billions. Now we face an even deeper truth. Even our universe may not be the first or the last. Perhaps the cosmos itself is conscious, not in a human sense, but as an endless process of awakening. Perhaps Methuselah II is not an anomaly, but a clue, a signpost left at the edge of time saying, "You were never alone, and you were never first." The James Webb Telescope has given us more than data. It has given us a new sense of wonder and a new humility. If the star it found truly predates our universe, then creation is not a single explosion of matter and light, but a living story still being written. And somewhere, in the vast silence between galaxies, there may be other relics of forgotten universes, stars that remember what came before, still shining through the darkness to remind us that even time has a memory. Because perhaps the real miracle is not that the universe began, but that it continues to remember where it came from.